particular, okay, now that I see that we can start it. So we are after the GDAL, you know, after the GDAL, the use of GDAL info to understanding the data type in terms of, okay, we see the minimum maximum pixel resolution, extent of the file, and so on, precision of the extent. So these are all aspects that are very important. Now that we know what we have in our directory, there is we are going to see several examples how to use GDAL for different kind of operation. One of the most important one is the typical band combination, okay, band multiplication. So in this case, and pay attention that all this work, all these software, GDAL and also PK tools that are going to work with many band or many TIFF files, they always working very well if all the TIFF file have the same size in terms of extent and pixel resolution, number of row and number of pixels in row, number of pixels in column. Okay, so that's why it's very important to use GDAL translate and GDAL edit also for the final cropping, because we want to be sure that the two files that we are going to use it are the correct one. Okay, so in this case, we enter in the directory that we are going to use it, or even better, let me open also the Jupyter file. So here in the beginning, for the one not, you can see, be careful, here is not Jupyter Lab, but it's Jupyter Notebook. Now you should know. So you enter in the media exercise over here, and then you do Jupyter Notebook. Okay, and you do GDAL OSGeo Python, okay? And as I mentioned to you, I quite open, I let this terminal open with a Jupyter Notebook open, and I open another tab or with a directory over there. And I can even enter in the same one. This way, if I need to do something, I can be there. So over here, you could see that we are going to use two variables in particular, two raster file in particular, and are the, you know, the geodata vegetation, and inside vegetation there are two files that we are going to use it. The GPP, as you can see, again, I'm using the tab. So this one is going to be my standard deviation, okay? And what I can be sure that GDAL info is giving to me this pixel value that we say that has to be always rounded correctly, but we can see if the other one has also the same. If he has the same problem, we can keep it as it is, you know, okay? Also because these are single example that they don't go in a full processing chain. So even if they are slight different, is not a big issue. So as you can see, they are perfect the same in terms of pixel size. Let me see the number. So 700, 720 and 600, 720 and 600. So now I can make a multiplication between them.
Is there, sorry,
okay. It's a division. Yes, Mark.
Quick question. Is there a function that return like this is equal and then returns it true if they're like the same dimensions and number of pixels, stuff like that?
No, unless you code it.
Yeah, sure.
Unless there is one that is something that I discovered recently. Yes, there is one in PK tools that is called PKDiff that tell us, but actually I didn't use so much. I didn't use at all, so I don't know how it works. But this is in making the difference between two image. Okay, but not only a pixel level, not only a dimension, raster and Excel, but also at pixel by pixel, tell you where are the differences. So this is done mainly when you do, you know, two different kinds of classification, and do you want to see the difference between the two. Sometimes the difference are very few pixels, so you don't really notice, but it's something that we can investigate. Okay, you can build up a scripting procedure that give you, or you can do the typical grep to get a pixel resolution and then calculate from there. Okay, so in GDAL calc, as you can see, okay, so when you do GDAL over here, you do GDAL and then you press tab, it's going to list it all the command of GDAL. The one without Pi, oh, okay, the one with Pi, PY are with the Python extension. I mean, they are Python script. Rather, this one, they don't have it, like GDAL ADO, GDAL info, and so on. They are written in C or in C++, most of them in C++. Okay, so this one, actually, you can even open and see how it is written. In the C, no, because the C is compiled. So that one, this one is a binary format. Rather, this one is a Python script. And actually, you can do it in this way. You can get one, you can write which, okay, which is telling where this file is located. So it is located under the user bin. And now this file, you can see how it's written is a Python code, okay? You can do more and you can see how it's written and you can even understanding, actually this one is extremely short. Is you can see how, and sometimes I use it to modify this one and do what I want, okay? Especially if there are very small tweaks that you can adapt, okay? So if you open the GDAL calc, you can see that everything that GDAL calc is doing, actually this one, they even point, so yeah, probably these one are using all their internal script, Python scripting procedure before they were right over here. So we need to check even deeper what is doing. But anyway, what I want to say that the GDAL calc is using NumPy to do the operation, the matrix operation, because the TIFF are nothing else than matrix. In particular, this one identify the data type, be careful, data type of the output, not the data type during the computation, okay? Then we will see the other one. Then, okay, this one is the typical override. This one identify TIFF1 or TIFF2, A and B, okay, the two TIFF that we want to do the operation. This one identify the compression type. There are different kinds of compression. Usually I always use compression deflate, and this one is giving to me how much strong I want to the compression, okay? And this is where we make the multiplication, in this case, the mathematical operation. In this case, it's going to be that the floating, the first TIFF, and use it and read as a floating, okay? So even, okay, this one, it was already, probably as a standard deviation, so it was already floating, but it was an integer. Without this one, it was going to be treated as an integer. And then integer divided by an integer, give an integer, okay? So this one, by this one, is forcing this one, the computation be floating point, okay? Pay attention that Python, in order to avoid this problem with the float 32 that we mentioned, they don't have the float 32. They have directly the float 64. Okay, so but without specifying. The float, when you write float, means float 64. So inside Python, there is now these issues of precision. Okay. And this one we treat in the same way the other file, the number, the B, the letter B, the second one over here, and here we do the division. And then I do the typical tricks to adding a little small number to avoid divide by zero. But divide by zero give you infinity or not existing at all, and then you will get some error. Or we can even try to do it without this one. Okay, so this one is going to be our output that is going to be, again, float during the in the output and also during the computation. Okay, be careful about these tricks, because if you don't put this one, okay, if you don't put this one in this case, you are lucky, because these one are float, so will be treated as a float. But if they were integer, they will be treated as an integer. So probably this one is what Martin was mentioned before. Okay. And once again, be careful also about the data type, how the data type, sorry, no, the no data as influenced in GDAL calc, because sometimes if it's labeled no data, will be labeled as a no data. But if it's not labeled, it's going to be also done in the computation of GDAL calc. So always double check what it's doing, okay? I always sometimes struggling to understand to remove it, not to remove, because the GDAL edit we saw the other day allow to us fake or remove this labeling. So sometimes you need to remove it, run GDAL calc, and then put it back. But this is how you we work in these circumstances. And then we can even open this one directly, okay, to see our result. This one is the result, isn't it? Yes, the CV, okay. CV. Okay, I didn't run. Yes, right. Okay, as you can see, is I mean, is doing was few seconds. CV. It's missing one. Okay, I can get the GDAL info. Okay, and I can look, the no data is this big number, and I can even open to see what is going on. Okay, open with the OpenEV. And okay, once again, be careful about the OpenEV because it's not very fancy software. Over here, look here, you can see the number that is moving. So you can see that there is a variation. Okay, there is a variation of the pixel, but everything is the same. Why? I could already imagine why, because this big number over here, all the water, is not labeled as a no data. So the color is also stretched for this huge number. Okay, so but actually this one is changing. So we can even now make it correctly this huge number and saying that is going to be no data. So this one is a good example to even to summarize what we did last time. Okay, so what I do, I get the GDAL info minus dash mm to get the big number. Okay, that is not neither give me the full number. So now it's going to be with the program to identify. Let me see PK info if it's giving me the long one. Because PK info, you have it, we will have it. It's also giving to you the, let me see if it's, no, even worse, it's giving to me the worst. So we need to maybe you Google it and you see which is the last number, big number, and you pasted this long number as a no data, and then you do, okay, I fake it, but it's not going to be called. Maybe let's try it. Never tried with it. So GDAL edit, and then underscore no data. Never try to put a scientific number. Let's try this one. Let's put also the okay, 38. Let's put also the quotation just to be sure. Do GDAL info again. No data value is there. Now we try to reopen and see, okay, is not yet there because probably is not the real, precision number that we are giving. So there are different tricks how to get this long number that is not able to print. Anyway, we can figure out later on, but this is the way out. That's why, let's say, it's not colored. If you open, for example, in QGIS, you will see the variation. anyway, also in GDAL, you can specify in GDAL calc, you can specify the output, okay? You can specify the no data or data output inside here. And once again, you do GDAL calc and then just press enter and you have all the options, okay? So be careful about this one, that you can even specify the band, okay? So let's suppose that you have, you have a satellite image that has multiple bands. So if you want one specific band, then you do like this one, you say, okay, from file B, okay, from file B, you can specify that my band is going to be equal to 1. No, yeah, equal to that band 1. Equal in the sense I'm going to use the first band, okay? So from this file B, I'm going to use the band 1. Okay, now I don't put it because there is only 1. Okay, but this is, for example, when you do the typical NDVI, that you have the satellite image and you do near divide, infrared, or whatever. So that is how to do it, okay? Always remember this little trick of small number to avoid divide by 0. But this is the how to use it with GDAL calc. Now they implemented a lot over here. Once again, inside here, now I did also multiplication, but you can do also some if condition, okay? And actually something beautiful that they did a few years ago in GDAL calc, if you go inside to the help, yeah, probably calc.py, and you scrolling down in GDAL calc, all the GDAL command, and you scrolling down, you will see that there are the example, and in particular, there is one that is dealing with if condition, if the file is bigger than, if the pixel is bigger than 0 or whatever, you will get it, okay? So let's see if it's coming. Maybe also here you have it. So if you want to enter inside to the long manual, you can get, no, you don't, usually you have it. Probably because also sometimes the manual in some software, there are in different package, okay? So you have to upload the long manual to install it, the long manual in order to retrieve. Usually they were always there, but this time, maybe on mine. No, neither in this one. Probably they remove it. Maybe. Oh, okay, no. Yes, these are the one that I was searching. So if you go --help, you get the long help. Okay, GDAL, in all the GDAL, and these one are the example that you have it. They added in the last. You have the long description of each single command option, and then you have the example. In particular, this one, you look, yeah, this one, if A is bigger than 0, so set the value of 0 and below to null. So if everything is below 0, it's set to null. Okay, so you can do also this kind of logical interpretation, logical operation, even more complex. So when you search for the help, this is the syntax of NumPy, remember. So if you want to do something particular, you have to do a NumPy syntax over there. So search, maybe you will not find GDAL calc example, but you find a NumPy if condition, logical function, and you can write inside here, okay? And then going back to the example that we were just commenting with Martin over here, this one is a very nice way to have a little 10 by 10 raster file matrix, okay, that you can simulate what you want. You can see if a GDAL is doing correctly because it's very small matrix. You put the number that you want, okay? And you can use it two little 10 by 10 and see if the result is correct or not, okay? So this is a good way to have a TXT file, because this is nothing else than a TXT file and ASCII file. These are actually the first, this one is the first raster file coming from the old ArcInfo format, okay? And this is the way I usually test again. I'm not sure what I'm getting. I have this 10 by 10 file that I can use it and operate with my testing, okay, to see if, because sometimes you get an output, but you are not sure that is correct or not. So I do the testing over here, inserting manually this number, and I can do the math that is behind, okay? So this is a good way to use it. Okay, so over here is like you can see that we get the minimum maximum. We get the minimum maximum of my file that I just created -mm. Okay, as you can see, okay, it's getting correct. I don't know why, probably because it's very long. So the OpenEV actually is a correct now. Is the number was correct, but is not able to read OpenEV, probably because it's too long. Okay, but it's not just a visualization problem. But I can see, because my coefficient of variation go from 0 to 1, or a bit more than 1, and is floating point. So means that is correct, and my no data is correct, is labeled correctly. Because if not, it was not labeled correctly, this number was going to appear over here in the minimum maximum computation. Okay. Okay, perfect. So so this is another very useful command, the GDAL warp, that is mainly used for warping. They say they even use this word warping when we want to change projection. And during the change projection, you can see in GDAL warp there are plenty of option, and the typical one are this one for cropping. You can cropping in the meantime that is warping, and usually the T stay for target resolution. Okay, the target is the one that you're going, is the output resolution that you want to put it. Okay, so this output resolution can be changed, and here be careful, because we say GDAL edit is not changing the pixel value, but when you do the warping, they changes they changing based on the interpolation techniques that are going to use it. They change the pixel resolution. And over here, where you set the pixel resolution here, and the pixel value as a function of the interpolation technique that are specified, where it is, I don't see. Yes, over here with R, -R, should be somewhere. And over here are all the resampling method that you can use it, okay? Over here, now over here you can specify the resampling method. The resampling method are the typical one that can be used. Just to give you a refreshment, we have the near and all the one bilinear, cubic, spline, and so on. And this one has been adding in the last years. So the near is going to, the default is the fastest one, and is going to be used only when we want resampling without changing the pixel resolution and the value of the pixel, okay, of the value. So in other words, if I'm going to resampling a land cover, of course I'm going to, and I have 10 value, 10 classes, it does not exist 9.5. So I cannot do it an interpolation that is giving to me an intermediate value. So I'm going to use near that stay for nearest neighbor. Rather, if I'm doing digital elevation model, I'm going to use it bilinear, okay? And all these one, cubic and cubic spline, they are in order, because more you go in this direction, more you have a smoothness situation, okay? So bilinear is going to having just a 8 around the pixel, cubic is going to be 16, and cubic spline even more. Okay, so you have is even more smooth. So usually I always use the bilinear. So because I don't want to have too much influence from the nearby, from the faraway pixel. Okay, so you always, but the most important is when it's classical categorical raster, near, and bilinear when it's continuous. You can also do it nearest neighbor when the pixel resampling is very similar. Okay, you go from 20 to 22 or 25, okay, meters. So it's very close, so you don't need to do any interpolation between the pixels. Okay, so all these settings need to be setted, and be careful about also this one: source no data, the value of no data, and the destination no data. So what does it mean? These are very important because when you do the resampling, you don't want that your typical no data value -99 is going to be mixed with the pixel value during the resampling. Okay, so these are very important to, as a reading, or avoid to use the no data in the resampling technique, and also destination no data, the one that you want to put it outside. Okay. Then there are also some other one that you can do the cut line. The cut line is like, is use it, you use it an external data source to get the extent. Okay. I don't use it so much because for a simple reason, because it's making the cutting without so be precise on the border, okay, on the extent of the value. So I always prefer to use this one, insert manually these, than not using another file and having this one not really precise. Okay, so I didn't use so much, but it's something that they added in the last few years. Output format as the other one, all the compression that we see, the overwrite is composed, need to be say overwriting. Anyway, if not, you get a warning message. Then input destination file, okay? Input and destination file. And you have the typical line of GDAL. So over here in this particular case, you know, I'm going to using all this file here, we have Landsat land surface temperature. So in geodata, we have land surface temperature, and here we have 12 files. Just to open one, just to give you an idea. We are the typical Kenya, this is here in Kenya, and this is the land surface temperature. You can see that you have over here the pixel that's changing, and this one is just the water together with this one. Okay, so I'm going to do a warping of this one just to change the resolution. I'm not going to change the I keep the lat long, but I'm going to change the cropping, and in the meantime also changing the resolution. Okay, and in particular it was going so we can see GDAL info. Okay, so was going from this value. Yes, we can making 0.8. Actually, we can make it even smaller or larger. Okay, so we can do it 10 kilometers. Okay, so now I can run it this line, and you can see that now is name. So what is this concept of file name? When I have my directory, over here, GDAL info, file. This is my variable file. If I do echo $file, is going to print my full file name, including the directory. Okay. If I do it base name, is going to give me just the name of the file without the directory, so without this part. Okay. And if I do base name .tif, is going to give me just the string of the file without extension. So that's why I call it this one file name. And this is very useful because over here, I can keep adding information like, okay, diff underscore tmp 1.diff. Okay, so now my new file name is going to be adding underscore tmp.diff. Okay, so this is how you use the same information over here. Now I can go, let me put an enter here, and this way you can see. Be careful, no space when you enter the backslash. And here you can see that I use it file name, okay, underscore crop, okay. And once again, I identify all this one is going to be my variable. In particular, I put the curly brackets because after the curly brackets, I adding another part of the string, okay. So this one is something that you will see a lot of in my scripting procedure because it's very handy to adding something else, okay. And to identify more different kind of names and so on. At this point, my file, they will be cropped and also resampling at 10 kilometer resolution. So we can see I didn't specify the resampling technique. So it's going to be, look, I didn't, so it's going to be the default nearest neighbor, okay? So we can even try later. So let me run this one. Did I run? So I can run. So it's going to be the cropping. Okay, so it's going to, yes, it's going to warning that is going to use the no data, the -999. Okay, should be fine. So now we can see inside to the over here, we have more. We have not only the input data, but also the cropped one. And we can see immediately, again, check always the size because we are going to have 10 kilometer resolution, so it's going to be smaller. And now you can do the OpenEV, and you can see that it's more burly, okay? So this one is going to be nearest neighbor. We can even change it to nearest neighbor because it's the default. You can do the bilinear, and probably, okay, I don't see if you see that, probably is going to be a bit longer, a bit longer because the file are not very big, but bilinear is, and even now, probably you could see that they are a bit more smooth because they have interpolation of the nearby pixel. Okay. Okay. So, and of course, then over here, you can specify, if you go back inside to the GDAL warp, you can specify input and output. These two, they can be what? The projection information that we did last time, we did in this one, reference. Do I have it? Yes, this one, spatial reference, okay? Over here is the one that you can get the information. And in particular, you go here and you get this value over here, and you inserting inside to the line. So in other words, if I'm going now, I don't run it, I just fake the situation. So this one, my target resolution paste is going to be, so the be careful because here you have source, the S stay for source, and this one is for the target. So the target is the output is going to be resampling at this resolution, okay? At this, no resolution, at this -t underscore SRS is going to be, yes, so resampling reprojected at this particular projection information, okay? So quite often, you know, you go from WGS 84 to the local one. I quite often work at the global level, sometimes continental level. So, for example, I did quite often the European one, the LAEA, or the NAD 27, the American one, to VGS84. So, but I don't go state by state, but you guys, if you work in something locally, you can deal it with the local projection. And sometimes it's quite tricky. It's just a matter of trying and try and try until you catch the right way to do it, okay? Also in QGIS, you have the projection is done via, and actually in QGIS, when you do the reprojection, is going to build the line of GDAL warp, okay? So it's really giving the line of GDAL warp. As you can see, it's very fast. You can do massive reprojection, and is very handy. In the meantime, you can compress it. Always remember to compress your file, okay? Your file become really 10 times smaller or larger if you don't compress it. So always compress the file. So just keep this line, copy paste, and you reinsert the compression in all the is without, you don't lose any any value in the during the compression. Okay, let's move to this other part that is also quite important, especially for you guys that are working, that we are going to enter inside to the machine learning techniques, because especially for the supervised machine learning technique, and in particular the GDAL location info is giving to you the possibility to getting the pixel value at one particular location, okay? So if we go back, getting the file before, pay attention, you have the GDAL info without any kind of information. So with just a source file, that is this one, and I give you a number. I can put even, whatever we want. In this case is pixel and line. Okay, it's not geographical information, it's pixel and line. So in other words, if you want to see what is happening at 101, so in the first corner, okay, you get the value of that pixel. And this is also good to understand, okay, GDAL, where is starting from 0 to 1, we can find. So let's do 0, 0. Okay, let's see if we get a value. Yes, we get a value that is different. So actually, GDAL calc is started from 0, 0, is the first pixel over there. So all these information are really important when you want to see, for example, what is going in around the border of the file without opening, because you have a tiling operation or a filter operation. Let's see what is happening over there. Also because sometimes the image is big, or you are working the terminal, you cannot really open it. And so you can see, for example, what is happening is always first the X and then the Y. So you can see what is happening along the X value. I'm just changing, okay, X0, I'm just changing the Y, okay? So I'm going vertically down, X0, and just going along the border of the image, okay? So this is quite handy for for this kind of operation when you want to see what is going on in one location. Of course, I can do a looping at the same location towards all the file. It's something also very handy because it's giving to you the location, okay? The location, even if I put the geographic coordinate. So over here we can see, so you can run this line and you can see that it's very fast. Okay, so it's looping among all the stuff at this, again, it's not geographic location, it's pixel and row. Okay, but I can also, if I put just a particular location, I can also put geographic information. And again, it's going to be, again, X and then Y, okay? And this one is identified by this one, geoloc. And geoloc is giving to me that is VGS, is geographic information, and as a default, is going to be VGS84. Okay, yeah, is the default that of the file. Okay, if he has, degree, is going to be this one in degree. But anyway, geolocation of the geo file. Okay, be careful about this. The val only, you know, is removing whatever you have it here, the so-called report. Okay, sometimes it's useful because it's given to you for one particular, you know, it's given to you for each single. No, sorry, it's this one. Is given to you. So now it's computing for it. The lat long is given to you which pixel or line it is. Okay, so this is very useful sometimes. Okay, so for example, if I want to see this locate, okay, of course now it's going to be the same because I'm drilling the same location with all the file. So it's going to be this one. But if I want to retrieve, okay, in which position I am in my file is this one. Again, this one is P stay for pixel. I never understood why they didn't put C and column and line or row and line. They put P. But the L, so always remember the L line and then the other one is the opposite. Okay, so this is again, you can avoid this information, no, avoid, remove this information is if you put val only. Okay, so this one is given to you in each single TIFF, the different pixel value drilling down at these coordinates. Okay, so this is very handy, and of course you can do it for one point, but you can do also in different point. Okay, so for example, let's suppose that you let me run this one this way. I have my little script, my little text file. I have my geodata is going to be my fake file with X and Y coordinates. So it's going to be, I just create now with 2 coordinates. Of course, can be billion of points, no problem. Okay, and now I can use this file inside to the geographical location info. Be careful by redirect the text file inside to GDAL location, inside to the GDAL location info. So be careful. This one is because I'm using this file inside to this string. Okay, so what is happening here that I have it, the 2 point over here. I have 2 points inside this file. So this one is going to be for the first point. You can see here, you know, this one is going to be for this one. This one is going to be for this one. And then the same for the second file, second point, third file, first point, third file, second point, and so on. Okay. So this, and of course, I put an echo to just divide for you guys to see better. But if you remove this line, it's going to be your full script. Okay, for each single row. And then with this one, you can play to customize better, for example, your table. So for example, you say, okay, get a pixel value, but I don't know the lat long of this one. Okay, they are written here, but let's written also here. So you can do one is the we saw it before, paste. Okay, you can paste this one. We see before this command in the last lecture, paste this one, and be careful here, you have this format. And here you need to specify also the -d, the separation, okay? The paste, the separation is tab. Okay, so now it's running and I have my, you know, my 2 points. This one, they were my 2 points, first and second point. And this one, they were the 2 pixel value. Okay, so, okay, now I want also this one. I'm interested in only 1 pixel, only this one. Anyone can tell me. Only this one. I can do here.
We could do it with AWK, right? Before we, in the paste command, but that might be overkill.
Yeah, actually, that one will be better because in this way is getting only one. You can, yeah, but then you have to do it also here.
Yeah, that's what I meant. That's what I meant. Yeah, but that might be
Okay, so
overkill because then we're AWKing in each loop, right? So it's like,
yeah, you can do it here. You can do it in two ways. You can do it here. You know, I can get this one grep, and I run it over here. Be careful when grep you have the point. Sometimes make something strange. Anyway, so in this way you have only for 1 point. Okay, so you can play a lot. Getting the line of GDAL is very easy, but then you need to play with paste with different, because over here, for example, we have only one band in this file. So sometimes you can have multiple bands. So you can have, you know, for 1 point, that's 6 band. So over there, you need to play a bit with, as you mentioned, Martin, with the AWK, with paste, with the seed, with grep, in order to have your final table. And this GDAL location info is extremely powerful. I'm doing billion of data with a LiDAR, with the GDAL data, and is extracting without problem. It's never overkilling memory, and I mean, you have to really overpassing billion before to kill. Okay. It's super fast. You can, you know, you can even do it even, you know, if you want to adding not only one pixel, not only the pixel, but also the nearby pixel, you just adding another, you adding an AWK line that is giving to you this plus 1 pixel, or this one plus 1 pixel, and you rerun. Okay, so it's really super flexible at pixel level. Then we will see, Rosie was asking, can we do it at area level? So like a zone, the typical zonal statistic and so on. So that one is another easy MPK tools. But the pixel level, point level, pixel level, GDAL location info is the fastest that you can find. You can do it. Also because, you know, when you were working in R, you were importing your raster file, and then inside R you were doing extract. Okay, and before to do the prediction, you don't really need the raster file, because all the model are done in a table. Okay, so the raster file inside R, they were just all inside to the RAM without be use it for the modeling computation. Okay, rather with this way, you enter in R just with the table that you want. Okay, just with the table, nothing more. Okay, so this is where you really have all the computational power of Python or R for the machine learning part. Okay, without having raster files that are there because you have been cropping some of them, you know, and these one are all in memory that then they are not needed for the, you don't have it for the computation. Okay. Anyone was trying to do it? Actually, I never tried in Python. I asked Francesco to do it directly in Python, the extract find. So we will see which kind of solution will, with Rasterio for sure you can do it, but I'm curious to see how fast it is and so on. Anyone was using any kind of point extraction, I think, for different kind of modeling, or just statistics also? I want to share his experience.
I mean, I think I was the one that asked the question on how to do this. I've done it in R with, I think, 3 different packages.
Mm-hmm.
So with raster, it's quite easy. With Terra, I found the output has a weird format. So afterwards, you have to get it back into just a vector if you want it that way. And then I also tried it with stars.
Okay,
which I still have to figure out a bit because the concept is completely different of stars.
Mm.
So,
Yeah,
but,
actually, I didn't use I use it only in raster. I don't know in Terra how fast, how good it is.
It's quite fast, but I also only have like a small stack of So it's not thousands of images, only hundreds. So it's not, doesn't take too long.
Yes, of course. And then if you enlarge, you know, the number of image, the size of the image and the size of the input file of this one, of course, you will start to see the difference. Okay.
Definitely.
Because
Yeah.
also the raster file, you know, is very big, and then is going to be loaded inside to the memory in order to get just one point. Rather over here is sitting the hard disk and is going to be drilled only in that point. Okay. So is very handy, this kind of operation. And you know, for all the different kind of modeling, you always need to build up this table, okay? Because this one, they can be the different predictor. Of course, now we are doing, you know, we are doing like this, but then you can have also, now we are doing like this, but let's suppose that you have each one of these that can be the different predictors, okay? Yeah, you can build a different table, and with the command paste, you can combine the table. Be careful if one point is going out. Yeah, be careful about this. Yeah, let's do this example because it's very. I go back to the previous one. So this one was the original one, okay? So if one, this one, if one pixel is over the image, so let's suppose like this, it's going to be empty line, doesn't give you anything, okay? So pay attention about this, because if you remove this val only, it's giving to you a warning. You can run, is giving to you like location out, yeah, is off the file, no full details reported. But due to that, you are avoiding this, you are getting this line, this one over here that is empty. Okay, so for example, let's do this test. This one, okay, I put it back val only. Are all my pixels inside my image? So I can count. Okay, over here in the end, I can do the count. 24 lines, and then if I do it, you know, if I do a count now with a larger number, I can still have 24 because they are, you know, the line is there, but there is no value. Okay, so the line is there, but there is no value. Then I can do some AW command to see, is my line a digit or is my line empty? Then print it. So we can do it like this, AWK. Let's do it if is it empty. If my $1 is equal, so always, you know, when is equal, always 2 is empty. I'm not sure if it's working. Should be. You want to put in twice. Then print. So this one, it should print just my $1 empty. Look, now it's empty. And then I can say, okay, how many there are empty? Okay, it should be 12. So it's giving me 12. So in this way, of course, if it's a huge file, you can see if some of your points are out of the image. Okay, but be careful because it's an empty line. It's not something that is there. And then, of course, when you, you know, even if you do the paste with the different file, be sure that these two files that you're going to paste have the same row number, because if not, you get, let's suppose that you have only 3 points, you get one is missing the other. So always double check the result with some double testing and so on. Okay, but this one, for example, is very useful once I use it to see which tile I have to run, which tile, because you have your txt file and you want to see, and you have big huge points in the globe and you have tiles. in which tiles it is. So you can use this one. When it's failing, tell me. Or when it's within, then you tell me. So you can use it, this one, to see which file are inside there or not. Okay. These are used quite a lot in different applications. Okay. So play a lot with this one, especially now that you start to have, even if you make some fake points, you know, and start to use it with your data set. Many of people, they do species distribution modeling, where the lat long, this one is the lat long presence absent of an animal, okay, or a plant. So this one is how you extract the information, okay. So try to do it. Some other people, they have, you know, sampling area of an element in the soil, pH, like for example, Samuel was mentioned, the pH value in the soil or in the river. So all these one are usable for this kind of application. Okay. Okay, let's do this one that is quite handy also, always for this kind of, be careful about this, that is not something that I want to see in your computation for massive data process, but is good to know in case you need it, okay? Why? Because for a simple reason, because something is to work with text file and something is to work with TIFF. As we mentioned, the TIFF, the DBF, or you know, these are binary format, and when it's not text file, is a binary. There are the two solutions, binary or text file. When a text file is something that we can open with an editor, and we can see immediately the value, okay? Rather, when it's binary, has been reformatted from text file to binary, and the computer can read and write much faster than not text file. And also in terms of size, the text file is extremely huge compared to the binary format, okay? So in order to see what is a text file, you can always open with head, okay? You can open, you can see. So if you open a TIFF file with an editor like this one, you get this, okay? So it's very easy. Is this one a text file or not? You just open with the head. If you say something that you can't read, it's a binary, okay? It's a very simple way to do it. And then you have to check which kind of binary format, okay? And then if it's a TIFF, you know that you can open with GeoTIFF, and I mean with QGIS or with GDAL and so on. If it's a TBF, you can open with Excel or with the database format and so on. So, but this is the simple way to do it. Okay. So, but there are ways to transform a TXT file in TIFF. So we saw in the GDAL calc, but there are also other ways. And one of them is this one that is very handy also in some case. With the GDAL translate, you can use the X, Y, Z, and you can imagine X and Y is given to you the lat long, and the Z, the value of the pixel. So I can use my TIFF and I can create my TXT file. Yes, my TXT file. So now if I open this one, as you can see now, is getting a bit longer because this one is computational heavy for the computer. So if I open this one, this file, you can see that okay, you can see this one as the lat long for each single pixel. So it's starting for up. I think it's up and then it's going. So this is the Y. So the Y stay constant. So it's going down. Yes. So it's going from the first pixel to down. Okay. And then it's going to the second column. So this is the first pixel, the X, and then the Y. And this is the pixel value. Okay. So as you can see now, all my matrix is becoming a two-line, actually three-column text file with And this is going to be what is going to be my full dimension of the matrix. So if I get this number and I get my pixel, that is the dot TIFF, no? The dot TIFF. And I get these two number, this one times the other one. Actually, this one is another way. This is also cool to show. So this, by this, you get EXP, expression, and then times, and then you have, because these are special characters, so you need to escape. So this one is giving to you nothing else than the full length of this table, okay? Because it's nothing else, it's a Y and so on. But you know, this you have the lat long of all your pixels, so you can do something over here, okay? And can be useful to see, okay, what is happening in a lat long situation? Oh, I want all the value in this lat long, okay? So as you can do it, you can immediately grab this one, copy, and get my txt, and I see what is going on in one specific line. So in this case, x is constant. Yeah, so x is constant is going down in the y. Okay, so I'm going in one transect in vertical in one line. So and I can see that my, I don't know, my pixel value is changing. So it's very handy for this kind of visualization. I can see what is happening in the, actually this one is the, you know, is the border of my pixel. I can see what is happening in this particular line. Or is a text file, so I can even do an if condition to say, okay, if my column number 3, in this case, my pixel value, this one, is bigger than bigger than 2, but less than 4, print 1 and 2 and 50, just the value number 50. So let's run this line. So it's already there, so you can see the crop here, crop underscore TRH. So we can do that somewhere. Cat txt. Okay, somewhere I have my condition of AWK that I've been changing my pixel to 50. Okay. So now I can do it what? I can do the opposite using the same format. Be careful, I didn't change the format, X and Y coordinate stay like this, perfect the same, but I can take my file now and change back to 50. Okay. Let me put an enter here. So now I can run this line, it's already there. So my output is going to have the value in that condition. So I can open the same file, but the TIFF. I can do OpenEV, this one. And I can see that, you know, where I have my AWK condition is becoming, so somewhere here, yeah, somewhere, let me stretch, you can see the color. Yeah, somewhere here, I have all my value 50, okay? So this is how you change it, the pixel value in an image. Is the right way? No, it's not efficient, okay? We will see tomorrow and next time another way to do more efficient with the PK tools, because I go through the txt file. But sometimes, you know, it's good because you can see the txt format. And you can understand your pixel value, you can count. For example, it will be easy to count how many 50 you have. Or, I mean, it can be done also in another way, more efficient, but one example. Or sometimes I do it, if I want to do it, of course, here you can also, if you want just one line in the beginning of the, so here, if you put the dimension, the proj win, and you put the dimension of your image, you can put just one pixel line. okay, and you can see what is going in that pixel line without changing the full file to TXT file, okay. Or even better, the GDAL translator. We can do it. Look, so let's close this one. You do GDAL translate. Okay, so rather than the coordinates, you can put this one. Yes, this one, the source win. So the source win is given to you in pixel source win SRC. Okay, so this one is giving to you the location of row and pixel, row and line, okay, and the offset. So if I do like this, it's going to be only one. Oops, source win. One. Because no, I should fine. Okay, because this is the second one. Okay, so that one it should be correct. That one is the TXT. Yeah, done now. Yeah, so this one is only one pixel at this particular situation, okay? Because I'm getting only this one. If I want 10 pixel, you know, I can run it again, and now I will have 10 value at this particular location. So sometimes can be useful to have this, something that you can read immediately without opening the image and so on. So especially if you're working with a lot of image. Okay, and the beauty is that you have the pixel value, but also the lat long that can give you some additional information. Okay. Okay, so let's have a break, and then we do the VRT that is also very handy, this one. So we come back at so 35 plus 15, 40, 50. We come back to 50.
May I ask Giuseppe, what is the cat do?
Sorry?
May I ask what is the cat? CAT
Okay, the cat is printing.
Head, right? It's
Cat
the
is
same
printing.
as printing.
Yeah. Head is giving to me only the first 10 lines as a default. Okay. Cat is printing all the text file until, okay. So this one is only the first. Okay, now the cat is only 10 lines, so it's short, but if not, it's printing the full file. Okay. This one is very handy for any kind of text file, even scripts. Okay. So it's very useful. You will see a lot of example of using cat for printing. It's just printing the full, open the full file, you know, no matter which size, it's going to print all of them. Okay.
Thank you.
Yeah. You're welcome.
Can I ask a quick question as well?
Yeah.
Not so much related with what you explained now, but I had the problem that sometimes my virtual machine got stuck. And what is the best way to interrupt or?
Okay, is stuck in which sense? That is frozen completely, or?
Yeah, that then I see nothing except like something that looks like a console.
Okay, so let's, and this is for everybody. When you be sure that you guys probably have, all of you have quite modern and powerful machine. I mean, machine, a laptop. So be sure that over here inside to the, you know, setting, you can increase the RAM and the CPU. So be sure, you know, that over here you have, okay, no, and this one is not active because the machine is on. So for example, shut down the machine and increase a bit more the RAM, of course, without passing the green. Okay, just stay closed, but try to be sure to have more than 4, 5, 6. And then the same for the processor, okay? 8 processor, okay, now I'm working with 1, but I can give you easily 2, you know? So do the same, it should be better. Then sometime if you have some something that is getting stuck, even OpenEV or QGIS, this is useful for everybody. You can do P kill, and P stay for the pattern, you know, and P, you can type whatever you want over here, QGIS or Firefox, okay? And this one is help you to kill the program that is stuck, okay? Be careful that, you know, if you type a word like fire, probably there are other software that are using this word fire, and it's going to kill also that one. So try to use always word that you know. Probably QGIS is the only software that use QGIS word, you know. Then it's depending in which kind of way is stuck, okay? But this one will give you already some solution, okay?
Yes, thank you. And but when let's say, okay, I increased the RAM and the CPU and everything, but still I get this problem again. Is the best way to reset it via machine reset, or just shut down? Or
okay, yes. So if you really don't know, okay, if you have the console that is working, you can also do it reboot. And this one is rebooting automatically, okay? Or if even the console is not working, sometimes can happen, always from here, you have the machine, this one shut down.
Yeah, okay.
It's really the shutting down, or there is also the other one. Yeah, so this one is the forcing the shutdown. So this one is shutting down the machine. So this one usually is the, and there is another one that say power off, or even close also is fine, as close is a bit less strong, the shutdown. So by this one usually, yeah, sometimes can get stuck. I mean, the virtual machine is good for learning, but later on you will pass to a full installation, you know. Okay.
Okay, thanks. But I will try to increase my RAM and CPU.
Yeah.
Probably that will help.
Okay, so let's come back to 55.
Okay.
Okay.
Hey, thank you.
Me now?
Yeah, now yes.
Cool. So that's the first thing on the recording now. Anyways, I had a question as well. So if you in the console just did what you did earlier, just type GDAL translate or any of these commands, and it gives you all the options. I noticed some of them have a star at the end and some don't. I was wondering what that means, or
no, the one, oh, wait. This one, no, the one that you get, you have the star is when you have a, actually, you know, I don't know.
okay, no worries. No, you do have it in some of the options in functions have stars at the end as well. Maybe if you need a file or something?
In the, okay, I get it. In the manual.
Yes, exactly there.
Like where?
For instance, in yeah, for instance, yeah, or in the line above as well. Or...
that you can put one more than one.
Oh, I see.
Okay, so like, yes, good points. Thanks for pointing. So for example, in the G, this one, the dash CO that stay for O option and C, I don't remember, but is the typical situation that you can have two, 1 and 2.
Yeah.
Okay, one for the compression and the other one for the level of compression. That's why you have more than one. Yeah, good point.
And then for any kind of, so for instance, same function, like Is there an example here? Like, for instance, the NA value, right? And you can specify the source NA value. I assume if it's a TIFF file that has that specified, then it takes that automatically, right? Then,
Perfect. So GDAL is using, yeah, good point.
but if
GDAL
it's a
is
text file that doesn't have this information, then I'd have to specify it.
Yeah, good point. Yes, if it's a text file, he doesn't know which one is the text file. That's why you need to give the destination value. And be careful that here you can have more than one value. But frankly speaking, I tried a couple of times and it was not working. And because you can give one space and then another one. But when you put more than one value, you need the quotation. So I didn't use so much. We need to investigate a bit more how it works, you know,
Behaves,
but
yeah.
is a possibility that they insert a couple of years ago to put more than one value. Yeah.
Cool. Thank you.
Okay. Anyone else with this nice question? Okay. We keep going with the new part. I mean, with the continuation of GDAL, and we were over here in the VRT. This is something that is extremely useful. Not this one. I think I removed one. Ah, no, it's correct. Okay, so the VRT is stay for V, stay for virtual raster, T probably format or tiling, something like this, and virtual because is not considered is considered a geo file, but is not considered a full TIFF as it is, and virtual is because is not a real file as per se like a TIFF, but is nothing else than a pointer to files, to some files. And let's see, because it's easier to show you than not explain it. So in this particular case, we have this input file, okay, that we have been seen before. In this case, we have two, you know, the mean and the standard deviation. And I can create the so-called stack file, the stack layer, and using the VRT format. Be careful. Now, what is going to have, you are going to have this file, this VRT file, that if I enter in vegetation, in geodata vegetation, so now this VRT file is over here. Look, is extremely small. If I do -K, you can see that it's just a few bytes. It's extremely small. It's not big as a, you know, we were combining the mean and the standard deviation. And over here, you can see, actually H, no, okay. You can see here that the TIFF, the mean and the standard deviation, they were 1 mega, and here the stack VRT is nothing else than few bytes. Okay, why? Because it's just a pointer that tell me which one are the file that are informed. Okay, so now standard deviation mean. Why I don't have the other one? Okay. Strange that it is not listing the other one. Stack VRT. Because they are two bundles. Sorry. Okay, so I will explain now. So over here you can see. No, over here the does not support north-south resolution, skipping vegetative.
I don't have that error on my end.
Okay, I think because I modify a bit the file. Because probably it was. Let me check another. Okay, let's make, rather than having the mean, we do the CV. Let's see this. Probably I did something with that file. No, I get the same. Okay, let's do twice the standard deviation. For the ET. ET standard deviation mean okay, so I repeat the same file, but is the same concept. Over here, I have, let's suppose that these two are two files differently. So now my stack file, my stack VRT file is going to be a very small file with two bands, okay? So I'm nothing else and then to create these two files like this, okay? But I'm not creating a new file, I'm creating a VRT. And the option of this one that you know, you have two different files and you can merge in a stack, but it's going to be not a full replication of the file, but just a virtual file. And if you consider this one is nothing else than a text file, and you can open, okay? It was in geodata. Stack VRT. So if you go this one, just to show you that is a text file, you can open, and inside here you can see the typical information of the projection, and then below a bit below there are going to be the information about the file that you are going to open it. Okay, so this one are the file, the source file. Okay, so it's just nothing else than a text file having the information that is pointing to the file that is built up. And this VRT file are built up with the file, with the command build VRT, okay? You can also build VRT. So you can also having a VRT file for warp from GDAL warp and GDAL translate, but most of the time I always do it with the build VRT, okay? So pay attention that the build VRT can be built in two different ways. With the option separate, so when you have overlay of the different TIFF, so you create a band, a stack file or a band, or when you have a tiling system and you have a mosaic, so you have different tiles. Let's suppose that these are my tiles and you just make it the typical mosaic, okay? One side to the other one, okay? So in this case, this one is the one that is really making the difference is the separate. So once again, if there is a separate, my tiles, they are going to be one on top of the other like this. And of course, they are going to be under the same extent. Rather, if I remove the separate, they are going to be just like tiles, one aside to the other, in according to what? In according to their projection, like extent and resolution. Yeah, extent and when they start from the lat long, from here, you know, from this one. So in my case, this file, they were all inside to the same square. And of course, they were going to overlapping like this, okay? Rather, if they are in tiles, like the typical globe, you have a globe tile divided in square, they're going to build in this way. And once again, they are very useful because you can use it to replicate a full globe by merging all the tiles, but without creating a big file. Okay, so this is extremely handful for the situation that, you know, when you're working with the global level, high resolution, and so on, you can't have a file of more than 4 or 5 giga. Don't work in that direction. Don't create a file of 8 giga because you can't really work. Every time that you have to do something, it will take age. But you can create 8 tiles, each one of 1 giga. Okay, so try always to not to go in the direction of having huge file. Okay, because is time consuming. You can really process it. But what you can do it rather is having split it let's do it in 4 because it's easy to manage it 4, but it's going to be the same if they are 200, and then merge it by the VRT, okay? So in this one, we really see an example over here how to do it, okay? So for example, we have a little file, this one. We have, actually, we have the file that we just created, okay? That we have the VRT. We can split this VRT in different square, okay? So each one is going to be my teeth, upper left. So I'm just divide everything in 4, okay? Upper left, upper right, low left, low right, okay? So, and I'm giving what? I don't give it the coordinates because if not, it's a bit more complex. I just give the pixel low resolution. So this one is the 00, so the one starting from the upper left corner and going down, and I have the 4 square of each single square, okay? So now if I run this one, okay, what I'm getting this file that inside vegetation, you know, they are going to be splitted perfect in vegetation, no, geodata first, vegetation, and then stack, okay? So I have my T file, and if I open 4 of them, you can see that are the 4 tiles, okay? So you can unplug each one. Oh, sorry, yeah, smaller, yeah. So each one was this one. This is what I did, okay? Now what I can do I can do the process, the inverse process. I can, by these tiles, I can rebuild and create a VRT that is merging the 4 tiles, and then with the second line, I can create my GDAL translate. I can recreate my mosaic, okay? So once again, this one is giving to me each single teeth, and this one is reassembling my tiling operation, okay? So why I'm doing this? Because each one of these, you know, over here, I can do something with this small file, okay? I can do something also here. I can do something also here. That can be a GDAL calc, it can be any kind of operation, okay? Now, of course, I didn't do it just to simplify the operation. And then when I have the output, I can rebuild my VRT and rebuild my T file. And the advantage is, you know, that over here I can even write, when after that they split it, I can even write a for loop. Or later on, we will see a multi-core for loop that each single tile will go in one processor, okay? Because keep in mind that these GDAL warp, GDAL translate, they are really low in RAM requirement. So it's very easy that you can go in multi-core operation without filling up the RAM and without frozen your machine. Okay, so there will be, we will see later on some option to go in multi-core operation in this case. And these are the VRT wire they are useful to split it. Okay, the GDAL translate make the splitting, but then the reassembling is done with the VRT. Okay. And once again, can be done in this operation if you have the separate option, so one on top of the other, or they can be in a tiling operation by the VRT. And this one is extremely fast, okay? You can you can make a VRT with 1,000 tiles. It will take probably less than 1 minute, okay? Because it's just a pointer. And then the advantage is also with the, you know, with the GDAL calc that we, sorry, not with the GDAL calc, with the GDAL location info. So let's suppose I have my VRT. Yeah, so this one. Let's suppose that I want to, so in other words, this stack is nothing else than the merging of these, okay? So if I want to I want a location, I want to a pixel value in these files, but I don't know which one it is. What I do, I build up a VRT and then I point to the VRT. So I do, okay, give me pixel number 3, whatever. And this one is giving to me the value for band 1 and band 2. Okay, they are the same because I used the same file. Okay, so now in other words, I'm pointing to the VRT, but it's taking care in which tile is the point information over here is. Okay, rather before, okay, before the VRT, like before you were going to loop in this one, okay, it's not there. This one is not there. Then it is here. So the VRT is extremely helpful for this kind of operation. Once again, now I have only 4 files, but you can imagine huge amount of file operation. Okay, and it is useful because each time this one can be an independent operation, then you can merge. Or let's suppose that this one is, is a huge file, 10 giga, okay, 10 giga TIFF. So you split it, and then now is 2.5 each. So you can do the GDAL calc without problem, okay, rather than waiting the 10 giga file to finish, okay? So it's very useful because this file is going to be extremely small, so you can operate as you want. Okay, so can be used for pointing, for merging, for this kind of operation. Yes, Rosie.
Question. So how did you know what exact points to cut it into quarters? So obviously starting at 00 is obvious, but how did you know that 360 and 300 were the exact?
Okay, so in this case, you do a bit of map, a bit of math with the image, so you open the image. So in my case, this one was the input, yes, so this one. So you do the GDAL info, you know that are, you go here and you do, so 700 divided by 2 is 360. So you start to make the quarter, okay? So it really depends. Sometimes you do it, in quarter like this using pixel line, and sometimes you do it with global, with geographical information. Okay, then of course you don't do the source win, but you do the proj win. Okay, so you do the other option. Translate. You do this one with the proj information. This one, proj win. Okay, of course you have to do a bit of math in your mind. Okay, I'm going to divide by 2, and then of course if you have a full globe, for example, a full globe, what I have one file that I done 20 years ago, where I have all the globe divided in 1 degree, 2 degree square, 2 degree square. So I have one globe, one file that is giving to me 180. Okay, so minus 180, so minus 179, and then 90, and then 89. Okay, so these are, for example, the one on the corner. So I have one file that is like this. So this is the first line, and then the second line is the other one, 78, and you keep going in that 79. And then this is the second line. So I have one file that you can even do it in Excel with divide by 1 degree, 2 degrees, 5 degrees, 10 degrees, 6 by 6 degree. And then you use always this one as an input for this. Okay. And you split your full globe.
Perfect.
Okay.
Thank you. I understand.
Yeah. Yeah, actually, I have to say that this is quite often is more time consuming because you, especially, okay, now that if I want the global level, I can use this file and I can loop in. But if you have a study area, you have to do a bit of math to divide by 4. sometimes I divide by 4. Sometimes you can do in stripe. In this way, you change only one, you know, and maybe you can divide by 10. This way it's very easy to divide by 10. So if one tile is smaller, it's not a big issue. Okay, it's going to be ending faster, the computation, but it's not an issue, especially the last one, you know, that is everyone is 5 degrees and then you have one of 2 degrees, doesn't matter. Okay, so always try to have, you know, integer number here. In this way is also easy to count, to see, you know. If not, if you start to have different value, then it's more complex. Okay, so anyone was using already this VRT in some computation?
I haven't used it. Well, I ran across a situation where it would have been really useful. We had it was a global product, but all the tiles were in some obscure folder structure. So it wasn't all the tips in one file. It was like sorted by agroecological zones and then another subfolder and another subfolder. And that actually brings me to a question. So when I looked at the VRT as a text file, it tells me the source locations, or so the TIFFs are stored in relative location, right? Relative to the VRT. So if I want to move all of the data, I of course need to move the TIFFs and the VRT. So
yes,
yeah.
Yes, in that case, good point, but also GDAL stack VRT. So Martin, this good point over here. So over here is giving to me the relative path. Okay, but be careful. If I go 1 level up or even 2, and I do it again, so now I give you the full path. So it's going to be my SC data, and then exercise. So now is going to be the full path. So now it's changing. Okay, so it's quite clever in this context. Of course, if you move it, I think is broken. So if I, you know, I copy this file and I put in /tmp, probably is going to over here, stack GDAL info. Yeah, look, he's reading the file, but he lost where they are the file. It doesn't know anymore. Okay, so of course, every time you can't really move the VRT. You can call him from anywhere, but has to be in the same directory where you created.
But if you moved at the same time, if you moved the TIFF files in the same relative location, would that work?
We can try. We can do the same. Copy. No. The VRT now. So we should call this guy the stack. I'm not sure. So this one, no? Yeah, stack. Dot diff. So now inside my TMP, I have the TIFF and the VRT. So now let's see if it's pointing. Maybe yes. No, but probably not.
So you have to recreate it. So if you have to move the data,
still get it. Look, because look, no such a file or directory. Okay, now it's pointing to the wrong file. You can test it. Usually I rebuild also because it's so fast, you know, that just a second to rebuild. Yeah, rather than but of course when you build, Martin will say, you know, this one build VRT. I don't have it in there. No, okay. Because I run it here. Oh, okay, I can over here. So this one, okay, now just for you know, they are in the same folder, but each one of these can be in different folder. Okay, so now they are in the same folder for a didactical purpose, but they can be anywhere.
Mm-hmm.
I build up VRT with 45 different folder, no problem. Okay, once again, be sure that all the file they have all the thing. Actually, pixel resolution is going to complain. Extent, no.
Yeah, should be fine.
Extent should be fine. Pixel resolution is complaint, but also projection information is also complaint, of course, because it doesn't know how to overlapping. So just to be sure that all these all these pixel resolution extent are in the same format and character. Okay.
Mm-hmm. And then can I, so in this build VRT command, can I also supply the TIFFs with like a star in the name, since I have like 10,000 of TIFF?
Yes,
okay.
yes, yeah, you can do it. Yes,
Nice.
you can
I
do
think,
the expression. And if you can also, you know, we can also see some other aspect. We can also, this one, the change resolution, I didn't use so much. It doesn't change the resolution until you call it, the file. Okay, so that's why I didn't use so much. But of course, I use it the crop, and actually, again, is not cropping the source. Is going to be himself that is cropped. Is just smaller, and every time that you read that one, is going to read not the full archive, but just the cropped area. So that one I use quite a lot. This one, as I mentioned, not so much. Separate is the option that we saw it. This one allow projection difference. There are some cases, that the projection are the same, but the metadata are different. Okay, because they come from different source. Because, for example, also the NAD 27 from United States, the VGS 84 is few centimeter difference. So, and then you are working global level, you want to merge these two data, and you merge it without ignoring this few centimeter difference. So they inserting recently this one to allow the projection difference. This one is also very useful because you can change the data from one to the another one when it's going to rewriting this one. And this one is together with this one. I didn't use so much, but it's going to be useful when you read. And this one is in line also with what you did it. You can even give a text file with all the input. Okay. Frankly speaking, I didn't use so much because we know how to use the regular expression. So I don't use it to build up a file with my name file. Okay, I just use regular expression to feeding the build VRT. Okay, so try to use it because it's super handy. Okay, so especially when you have several tiles, it's very. Anyone already thinking how to use it and want to share it? Anyone? Samuel, you can downloading all the geomorpho 90 the hydrography 90 meter tiles, and then you can use this one to rebuild the full globe. Okay, so this is how you do it in an efficient way. Try to use it as much as you can, the build VRT. Okay, and even GDAL warp can GDAL warp or GDAL translate. Here I can even use it a VRT. I create a TIFF just for didactical purpose, but also here, if you do it output type, output format. Now I don't remember output format. I think it's VRT, and now I don't remember this one. Now I think it's capital uppercase letter VRT. Then this one you can become a VRT. Okay. And the same for GDAL warp. Not always, but quite often you can do this kind of, and you will see that your processing is extremely fast because again, it's not a full file, it's just a pointer to the previous file, to the TIFF files, okay? You can do also VRT of the VRT. I did it a few times also, you know. For example, you have different tiles of two bands. First band, one tiles, one layer, a second band, another one. And so you want to do the first VRT, the full globe, and then another band, the full globe. So and then you do the VRT of the VRT. You can also do this kind of always test it before to see what you want. But it's very, very useful. And feel free to play with all this, you know, in the folder here, you have plenty of files that you can simulate this kind of operation, you know. Yes, in the geodata, you know, you have the LST that you can have. This one you can do the separate like this because they are in the same area, but you crop it, you cut it, you can reassemble it. So start to play a bit with this VRT. Something also extremely useful is with the tile system is this one, okay? This one is creating tiles, but in vector format. So for example, we have again this one that we just created, okay? This one. Let's suppose, okay, I have 4, let's suppose we have 20, and we don't know where they are. We don't know how they are located in the space. So with this one, you can create a shapefile that has just the border of your tiles. Super useful, okay? You download the modis, and you know the modis, they are in overlapping. You say, which one? Okay, you download the full United States, and then you want just 4 of them. And you say, which one I'm going to open? I don't know which one. You build up this one that we are going to open. I am in geodata, / vegetation, / tiles. Okay, so also this one you can open, it's a shapefile, you can also with OpenEV. Okay, so these one are my 4 tiles. Okay, they are, but okay, now they are in 4, I mean 4 really precise, but it can be also in overlapping. Yeah? You will have each one is nothing else that your border of the tiles. And now we are open a vector file, so it's going to be extremely fast. You are not opening each single pixel. Okay, so and again, this is extremely useful where you download the full data set of MODIS data. Sometimes you have the MODIS, the Landsat, you have a full folder, and you have a bunch of HDF, okay? This one can even read the HDF. Okay, let me see where they are. Boom, you create these, and then you open. And then, of course, with this one, you open a country border or, you know, OpenStreetMap, and you can see where they are in the United States, in which site. Then over here, or even in QGIS here, the beauty that you have also the information of the tiles, you know, so you can click over here and you can see the file. Okay, so super useful. Okay, I need this file to open, and then you can open directly this one. Is in the attribute table of the shapefile. So in combination VRT with this one, you avoid a lot of areas, you know, because quite often, you know, you have the TIFF file, all the TIFF file or the HDF file in one folder, and you don't know which one to download it. And then you have to go to the graphical user interface that the NASA built or some other. I don't do it, this stuff, you know, I just go there, I download all of them, especially if you work in the server. You download 1 giga or you download 200 giga, you don't care, you know, especially if you have a fast connection and space on the server. You download all of them, you see which one, you build up this one, the TIFF, you say, okay, I need this and this, the other one you remove it, okay? So this is very handy in this. Sometimes there are some sites that they give you this file. Okay, they give you this tiling shapefile tiles, but quite often not really. Okay, Before I was creating by myself. Before I was getting the coordinates, I was creating points, the centroid of the image rather than not the, but this one is very handy for this kind of stuff. Okay. You like this one? Alex? Is Alex there?
Yes, and I would like to ask one small question.
Yeah.
In case we have special tiles like this, and we need to perform some operation which involve neighborhood or focal analysis, like, and some of the places will fall on the seams between or the joints between different tiles. So how does this handle such a situation? Will it be some overload on memory or like this when
Okay, so in this one, this command in particular that I'm dealing, this one is creating just a vector file around it, the tiles.
No, I'm sorry, I'm talking about this VRT rasters when we are analyzing
The
different
VRT,
tiles.
yeah, yeah, good point. The VRT is just making the merging, okay? It doesn't do anything, actually. If there are two images that they are in overlapping, like this, you know, he will keep it as it is. He's not going to do anything. It's just a pointer. Then it's depending from the second operation that you do it, what is going to happen. Good point. So, for example, if they are like this, and GDAL, and you run a GDAL translate on something that is like this, is going to get the first one. Okay? And it just ignoring everything. But if this one is no data, it's going to get this one below. Okay? So if you want the merging of this one, we will see PK tools. Okay, the VRT doesn't do anything. It just say, okay, these files are together without merging them in a pixel resolution. Okay, but really good point. And the same if they are like this, they will be in separate mode. Okay, pay attention that actually, look, now I'm not sure if it's translate is the last one or the first one. I'm not sure, you have to check. Remember that the no data is going to be transparent. Okay. So it's going to get the following up. Yeah, so these are the main point that you can figure out. So I use it quite a lot for the match because I'm working a lot with the hydrological basin. You know, each single basin can be in a different tiles. So I use it to remerge it, and my zero is my no data, so I can recreate the full globe, okay? So over there is where I use a lot of this VRT with a separate or without separate. So always think what you have to do it if you use it a separate option or not. Okay, so let's try to finish up this part. You can create with the GDAL proximity, I think was coming up a few weeks ago as a question. You can create a buffer distance. Okay, you can create a proximity distance, so like like a distance. So if you run these two, and you can open easily. How I is written this? Yeah, proximity. So I can go to the same file. So if you do LL-RT, you are listing the last file, you know, that you are creating. R stay for reverse and T for time. So you can always click, check which one you open it. You just creating, open EV. So you can see that now this one was my input data. I'm getting proximity from this point. I have several points. And this is going from pixel level or degree level or meter. You can select, okay? And then if you're forcing, because then from the proximity, you can do it the buffer, you know, just say less than 4 kilometers becoming a buffer, okay? So you can fix the buffer distance over here with the maximum distance, and you can having also the buffer. Okay, this is quite new. This was adding a few years ago. Before there was not any buffer. So this one is the buffer, you know. And this one is also quite fast. I really use it a lot in these last days, actually, for some disease issues and so on. I mean, not my disease, a vector-borne disease that we are doing. And this is the buffer. And of course, you can specify the value inside the buffer, the value outside to the buffer. You can play with this proximity, you know. I use it quite a lot also in to give information about the value of the close by information. So how far is my point and so on. So, and again, buffer, consider that these one are all raster operation. So they are extremely fast. Try to do a buffer in a vector environment, start to become slowly because he has to know where to go the buffer. Rather in pixel it's just a matrix, so he does very fast. There is also command for topographic variables. Okay, so using the GDAL calc, GDAL, in particular the GDAL DEM, you can get the slope, the aspect, the terrain roughness, and so on. Okay, pay attention about this one. Okay, and frankly speaking, GDAL is not very good for slope. Okay, pay attention. Because this one, you have to give this value, especially if you work in WGS 84, you have to give this value in according to the location of your tile in the north-south globe, okay? So this value works if you are at the equator, okay? If you are going in Italy, that will be higher in the equator, this one need to be computed in according to the location of Italy from the equator. I really don't like this stuff, also because it's a value for the full tile, it's just the centroid of the image. So if you are working very huge area, you have a distortion of the slope around the border. So the best way is to calculate the slope in grass. Okay, so do it in GDAL, but if you have to do something really slope relevant, you know, be careful. I want to warn you on this. So the typical, and then you can get also terrain roughness and so on. So these are fine, but this one, be careful, because with this number, I have an exercise. I will point to you how to do this one kind of assessment assignment. And then, of course, if you list it, there are plenty of them. Okay, I just list the most important one. And so this one, GDAL merge, don't use it because you have the GDAL build VRT plus GDAL translate. Okay, so don't really use it, this one. And also because it's much faster. Then you have this one, for example, polygonize from raster to vector. Okay, so this one is very useful also. And then you have also the other way around, GDAL rasterize from vector. Yes, from vector to raster. Okay, so this one, of course, when you go from vector to raster, you have to define pixel resolution, dimension of the raster, so all this stuff. So all this information, okay, the projection, no, because it will be in the vector, but this is something that you can also explore. Okay, so feel free to check all of them. Something I never use this one, for example. I think I used only one. This one is the multi-dimension in the data cube, so I didn't use so far. And this one, so some I didn't really use it. The compare is the one that you had mentioned, Martin, I think, and I think I use it one. And there is also a PK diff, that is the difference between, so you can search, you can test it and let us know how it goes. This one I never use it. This one is good for making color map, color tiles. So you have a lot of fill no data. Also, I use it to refill the no data with some particular value. So like if you want to extend the inside to the sea or something, no data. So it's quite handy, this kind of stuff. So let's see the OGR. So in the same kind of setting, we have the OGR command. Okay, and the OGR, you can, there are few of them, there are not so many as a GDAL, but you can do most of the operation that you can do in the vector environment. So cropping, you know, buffer, probably not. Clipping, overlay, intersect, database query, and so on. So all this kind of vector analysis, the most important one are GDAL info to get information of the file, and then OGR to OGR to get translation between one vector to the other one. This one, they have the typical option, the one that use it, and the advanced option is something that they adding in the last year. And you can do, you know, you can clip based on another data source. You can do the you can do SQL query inside to the database. So you can do a lot. Usually I always find, and I don't use a lot the vector format. So for me, few lines are enough to, and then I transform to raster. So, and I never get in trouble in using it. So let's see a bit using this data set is the typical globe vector file. Okay, just to let you see geodata, SHP, and then TM. Okay. So we have the typical global map, okay, that we can work over it. So you can easily list, you know, all the geodata, and pay attention over here. If you put the geometry no, you are not giving information about each single vector file. We can, if you remove these, you are going to get very huge information, and they all stay for the attribute. So over here, you are getting all the attributes for each single polygon. This is, again, is a text file. So we can manipulate with all AWK and bash environment. So if I want the stuff for, where is, whatever, FIPS, I'm going to say grep over here, grep, FIPS, and I run it. So now I have all the country. Okay, so that one is a text file. So I can operate as I want with AWK. Okay, if I want the largest file, okay, I can get the area and I can say, okay, give me the largest file. So it's just a text file. You can operate as you want with the info. Okay. Rather with OGR, for example, with the info, you work with the metadata of the file, with the text file. Rather with OGR to OGR, you can manipulate and create a new file. Okay. So for example, you can define the shapefile. Here you have the overwrite option that you have always defined, and I think it's giving you an error or warning if you don't reply. And here you can say, okay, where my name, because if you remember before there was one item that was called name, maybe we can set it again. -50. Okay, so here there was one name where there was given one attribute name, one attribute column name that was given name, that is the name of the country. And you say where name is equal to Uganda. Okay, be careful, even without many years, this one is the input and this one is the output. And I keep always making mistakes. So yeah. I don't know why they did in that way. It's completely not understandable, but remember, this is the input and this is the output, okay? If not, we will say, yeah, file does not exist because you are investing the situation, okay? And here is going to create the Uganda. So you run this one, Now you do the typical query and you have only the Uganda. So be careful here. You can even open OpenEV, but inside to the notebook, but you have to give the full path, okay? Doesn't work the alias, okay? So you can give the full path. And now you have only Uganda. So as you can see, it's quite fast. You can do, you know, simplification of the file, simplify vector when you are losing the resolution of your border. You can do, you know, SQL statement inside to the attribute table. Okay, where all my geometry area, my area is bigger than 100. Be careful that this one is 100 degree. Is not in or no, actually no, you're not. No, this one is probably in kilometer square. Anyway, you need to check in what is given to you the area, if it's really in kilometer square or so on. So you can do a lot. So try to really the assignment for next time is try to get familiar with the GDAL, with all the command that you have. Try to do some operation with your file. Try to build up already, start to manipulate, because now you have, let's say, 50% of the GIS capabilities with GDAL, and the other 50 with the PK tools. There are some stuff that you can't do it in GDAL, so it could be, but try, because in this way, then you can come next time and say, okay, I was trying to do this, but I didn't find. Is it GDAL or PK tools? Usually, whatever is pre-processing, you can do it. Cropping, change resolution, reprojection. You cannot really, you know, change pixel value or making a classification or, but in GDAL, whatever is pre-processing of an image, you can do it. You want to do it with one single raster layer, or you want to do it with a multiband, just do it, try. Is the best way to do it. Okay, do it your study case, use it your data, and because this one is going to be the first geocomputation part for the final project. Okay. Okay, so that's it for today. We overpassing a bit, sorry, and we will be here for some additional question in case it's needed.
May I ask a little bit about
Yeah.
the compression?
Sorry, about?
I might have missed this part, but regarding the compression, may I ask a little bit more about what it does?
Yeah, the compression is nothing else than compressing the size, you know, of the image. It's not making any change in the pixel. It's just an algorithm for different compression, you know. You have different kind of compression. It's like creating a zip file, but, you know, you compress TIFF.
Oh.
I mean, the zip, not the zip file, but the same. The zip is compressing everything. The TIFF is going to compress himself. You have different kind of compression. Usually I always use this one, you know, I test a few of them, and this one is the most efficient one. So, and then you have the JPEG, it's from Sentinel JPEG 2000, but usually when you do it, you know, where it is here, when you do it, yeah, zeta compression, zeta level 2, you know, zeta level 9 is the level of compression. Just copy paste this line everywhere that you create TIFF, you know. Then you feel free to work and see other options. So for example, look, is almost everywhere I think I use it.
Just use it every time we use the GDAL. I mean, just
every time that you use GDAL and PK tool, just compress.
Okay.
Okay, because it's going to be faster. And it's really compressing a lot, like 10, even 20 times smaller the file. So always compress, because it's very easy that you create large file. And also in terms of times is more or less the same, you know.
Yeah.
Time of computation. There are, if you Google it, there are different compression algorithm, and they give comparison between the compression, the size, the different time in processing. But more or less, I use always this one. Yeah.
May I also ask a little bit of the overwrite? Like when do we add that overwrite line? When do we not add overwrite?
Yeah, so in GDAL warp is one of the few that you need to overwrite. And also in you need to specify to override. GDAL translate does the override, but without warning. It just as a default. Rather than GDAL warp, you have to specify, please override. Okay, so be sure that some command, they have the option override, so use it. If not, the GDAL warp is giving you a warning, and also GR to OGR. So just read carefully the manual, because sometimes you have, sometimes you don't. If you don't have it,